Do is they have to pack all the tissue, all the things that they need to survive within this confined area that they have. And there are few places in the body where this confinement is actually very important.
The critical junctures in insects occur at their joints, areas where their exoskeletons pinch and they end up with traffic jams of trachea and tissue.
It's right here where the leg is attached to the body. Through this orifice, insects have to supply the air. They have to connect muscles by tendons. They have to supply insect blood through that orifice into the leg.
As beetles get bigger, the tracheal tubes begin to fill up the space in this orifice. A little math led researchers to a prediction of maximum bug size.
When we increase the tracheal dimensions to a point where about 90% of this orifice is covered by a tracheal tube, the hypothetical beetle is about 16, 17 centimeters large. And this is about the size of the largest beetle that we have on Earth nowadays. It's a longhorn beetle. It's called Titanus, and it's a Central American animal.
In our environment, bugs can get no bigger. But what if you had an environment 300 million years ago when oxygen levels were markedly higher? Oxygen levels in the Carboniferous atmosphere increased over time until they reached levels of between 30 and 35%, as opposed to today's 20% atmospheric oxygen concentrations.
Because we had a better oxygen supply into those structures, insects could actually decrease the size and the dimensions of those tracheal tubes.
Smaller tracheal tubes left more space for other tissues to grow.
They essentially were superfueled arthropods during the Carboniferous.